Dear students at home. Today we continue again our topic about the introduction to sequence. So we're still about the introduction to sequence before we touch up with the first part of the sequence, which is arithmetic sequence. So there are many things still that we need to study before we start up with the first sequence, which is arithmetic sequence. Now, today we're going to study about getting the formula. Okay, so as you will remember that last week we had about the given is the formula, and we have the domain, and we just simply substitute the domain to our formula, and we can get the value of every term, right? So, like for example, I will ask you that first give or first list the first five terms of the given sequence. Okay, so you will just simply substitute the domain to the formula, then you can find the value of each term. Okay, as well as to the next one. Yes, the next one. So we have here the general formula of the sequence. That is our topic for today. So you have here finding the general formula of the sequence. Okay, so for this we need the first few terms of the sequence that makes it possible to find its nth term. So meaning to say that we need like three terms or four terms, the first three terms, the first four terms, so that we can find the succeeding terms up to the nth term. Okay, we need that formula. So there would be three or more terms that are given to find its general formula. So we have your example, as you can see here, we have here the example of a sequence 2, 4, 6. So we need this one. Okay, so that we will know what is the trending, what is the sequence for every term. Okay, we're going to analyze what is the sequence for every term. Just like this. Look. Now here we have the sequence 2, 4, 6. Okay, etc. So this will be the even numbers, right? So every term you will see, if you will observe, every term starting with 2, it rises up with 2, right? So from the first term 2, going to the second term, we just simply add 2. From the second term, going to the third term, simply we add 2. Okay? And so on, we're going to add 2 for every term so that we can find the succeeding term. Okay? So by that, if the rise up of the term from the previous term is equal like this, so from 2, we add up 2 for this, we add up 2 for this, if the rise up is even, okay, or equal or the same at all term, okay, so we're going to multiply that rise up number to our domain. Okay, remember that we're going to multiply that rise up value to our domain. Now remember our domain start with 1, 2, 3, 4, etc. Right? So here, if we're going to multiply like this one, 2 times 1 as the first term, it's 2. Yeah, correct. We got the first term. 2 times 2 is equals to 4. Yes, correct again. And 2 times 3 is 6. So it's correct again. So our thinking about the sequence for this particular sequence will be rise up with 2 and multiply by 1, and we can say therefore that the formula that we can suggest is this: an is equal to 2 times n. Okay, so if we're going to have here 2 times 4, it gives you 8. Correct, because as I have said, in the first, this first and the second to the third, it give us plus 2, plus 2, plus 2. So meaning to say, getting the fourth term plus 2 again. 6 plus 2 is equals to 8. Okay, so if we have here 2 times 4, that will be 8, right? So therefore, our formula is an is equal to 2 times n, or 2n, for this sequence. Okay, did you understand? Okay, now We have here the second example. We have here 3, 6, 9, 12, etc. Okay, now as if you will observe again, from the first term 3, how much it rise up to 6, rise up to the third term, rise up to the fourth term. You will see that every term starting with 3 rise up with 3, right? So 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, etc. Okay, so the same method that we're going to use. So we're going to multiply that rise up to our domain. So again, we have here 3 times 1 is equals to 3, correct. 3 times 2 is equals to 6, correct. Again, 3 times 3 is equals to 9, correct again. And the last one, 3 times 4 is 12, correct again. So meaning to say, we can say therefore that the formula for this sequence 3, 6, 9, 12 up to infinity is an is equal to 3 times n or 3n. Okay? Did you understand it? It's easy. So remember that if the rise up of or the rise up or the low down of the term is equal to every term, then you need to multiply that one to our domain. Okay, so same like this or this one, we multiply that rise or down value, okay, to our domain. So therefore, try to remember that one. Okay, now we have here more examples. This. Now this one we have 1, 4, 7, 10, etc. Okay, now what do you observe? It rises how much? Rise up how much? Rise up by 3, right? So we have 2, 3, 4. 3 again, 4 plus 3 is 7. 7 plus 3 is 10, or and so on. Okay, so meaning to say that our rise up is 3. And again, if the rise up is even to each term, we multiply that rise up to our domain. Okay, so we have here, example. So we multiply again for the first domain, 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. But what is the result? Look, if we multiply this by 1, the first term, it comes up with nearly with the second term, right? It's nearly because we have 3, but here in the second term we have 4. But if you will observe, if we use this one, 3, 6, 9, we only lack 1 number. So we have 4, 7, 10. So if we're going to add here 1, you have add here 1, we add here 1, we will have the same with the second, third, and the fourth term, right? Okay, now if we're going to add 1 first, this, you see, 3 times 1 plus 1 is 4. Okay? If we have 3 times 2 plus 1, 7. If we have 3 times 3 plus 1, 10. So you will see that our result here, if we're going to add 1, 4, 7, 10, it is correct with the second, third, and the fourth. But the problem is, we're using the first, the second, and the third term for that. The domains. It must be start with 1. So how we can do it? Okay, now for this, if we can have like this one, we will start multiplying first with 0. Okay, so we can start first our domain to 0. And from that, we're going to evaluate to find that our first domain will be 1. So we're going to start with 0 like this. So as our first domain, but it's not really our first domain because the sequence, we must start our domain with 1, not with 0. But we're going to try with 0 first, and we're going to evaluate so that we can find that our domain 1 will be used to the value of the term for 1. Okay, now here, look, if we're going to multiply by 3, 3 times 0 plus 1, we give up 1. Okay, so how we can use 1 or how we can change 0 so that our domain is 1. Now, this the hint. Now, for 0, we can change 0 as 1 minus 1, right? 1 minus 1 is 0, correct? Yes. So we can have 0 as 1 minus 1 is equals to 0. Okay. From that, we can distribute 3 times 1 and 3 times negative 1. Look at this. 3 times 1 is this, right? And 3 times negative 1 is negative 3, correct? Yes. Again, 3 times 1 is this, 3 times 1, okay? And 3 times negative 1 is negative 3, right? Okay, so we're going to simplify this. We have minus 3 plus 1 is negative 2. So if we have 3 times 1 minus 2 is also equal to 1, which is correct for this. And you will see that our domain here is 1. We multiply the rise up value of 3 to our domain, which is 1, and give us the result of 1, and which is correct with here, right? So you will see that our result here is 1, and our first term here is 1, using the domain 1. Okay, so we're going to base our formula with this. So if we got the first term using the domain 1 and gives you the first term 1, we can also use this with the second domain and this one. Okay, again, we write this one again. So we say 3 times 1 minus 2 is 1, and followed by the second domain. 3 times 2 is 6, minus 2 is 4. Correct again. And we have the next one, 3 times 3 minus 2 is 7. Okay, that's 9 minus 2 is 7. And the last one we have 3 times 4 is 12, minus 2 is 10. Perfect. So we got up our formula for this sequence, and that is therefore an is equal to 3 times n minus 2. Did you understand it? Yes, just follow this one. So you will see that at first we start with 1, 2, 3. But if you will observe that we start with the second term. Okay, third, fourth. Okay, as we add 1, it's correct, but we start with the second term. So how about if we're going to start with 0, like this? We will come up with the same as the first term? Yes, we come up. But we cannot use 0 as our first domain, because as we know that the domains start with 1, 2, 3, 4, 5, etc. Okay? But we can make 0 as 1 minus 1, right? 1 minus 1 is 0. Okay, so we eliminate 0 and we change what with 1. Now, and we distribute 3 times 1 is this, 3 times 1, and 3 times negative 1 is negative 3, right? Plus 1, and we simplify this, negative 3 plus 1 is negative 2. So you will see that our value here, the number multiplied to the rise up is 1. And that is the first domain that we need. And you will see that the result is also 1, the value of 1, like this one. Okay, so if we're going to use this as we did this one, you see, the same 3 times 2 minus 2, 6 minus 2 is 4, 3 times 3, 9 minus 2 is 7, 3 times 4 is 12, minus 2 is 10. Perfect. So we therefore the formula is an is equal to 3n minus 2. Okay, more example. This 19, 13, 7, 1, etc. Now this one is